allow us to visually understand how the data is distributed. Okay, and there's also another kind of plot called the stem and leaf plot. Before were able to very easily demonstrate how data distribution using histograms graphically. We worked with text-based windows and computers where we couldn't display graphics that easily. And the way a stem and leaf plot works is that we take all of the males that are 65 inches tall, and there were four of them, if you recall, four males. So there were 65, so that's 65.000 inches. So there's 1, 2, 3, 4 males that are 65 inches tall. Well, how many 66-inch tall males were there? Well, if I go back up here, 66 inches, let's see, there's two, and there's one that's 66 and a half. So let's say 2 zeros for 66.0 and 1 5 for 66.5. So I can look at this graph and say, oh, well, gee, for 70 inches, there were 24 males that were 70.0 inches and one that was 74 and a half. And if I look at this sideways, this stem and leaf plot is kind of a mirror image of our histogram, right? So it's another way of displaying that distribution. Same thing for females here. Okay, and they're unimodal, right? Because there's one value that's the peak value, right? Now, if I had put these together and done this for the males and females together, what do you think I might have gotten? Would I have gotten something that was unimodal, or do I have a chance of getting something different? Anybody have an opinion on that? If I did a histogram, right, be a bit different, right? I might get a bimodal distribution. I might see something where there's a peak for the average female height, and then kind of a dip, and then another peak for the average male height, right? So I might have actually gotten something that was bimodal, had two peaks, two distinct peaks, rather than one distinct peak. Okay, we'll leave that exercise, or you can try that on your own to see if that happens. Okay, so you can actually go back and use analyze descriptive statistics, explore, and not put gender into the factor box and just do it as a single distribution and check off, do a histogram and see if that works for you. Okay, finally, the last kind of plot we're looking at is called a box plot. Okay, and as we mentioned, these lines represent what we call whiskers, and these whiskers, that are terminated here and here, represent the minimum value and the maximum value. The shortest male is 65 inches. The tallest male is 77 inches, 78 inches, something like 77 inches, it looks like, or 76 maybe, right? Those bars, those little whiskers represent the range of values, minimum to maximum. Now let's take a look at this grayed out box in the middle here. The bottom line here on this grayed out box represents the 25th percentile. And that would be like about 69. The top part of the grayed out box represents the 75th percentile. So that would be about 73. So 25th percentile to 75th percentile, that represents 50% of the people are between this value and this value. What's that called again? You guys remember what that's called? Interquartile range. Thank you, Lisa. Okay, so that's the interquartile range. Notice how narrow it is. That's because these values tend to cluster towards the middle. So that box is relatively narrow compared to the entire length of these values. Okay, so now what about this dark black line in the middle? What do you guys think that might be? You got an opinion on what that is? Okay, I'm thinking somewhere in the middle. A good guess on the mean. However, it's actually the median. Okay, there's a few reasons why we're using the median instead of the mean. That's actually the 50th percentile, right? The median is the middle value. If it isn't a perfectly normally distributed symmetrical distribution, then the mean might not represent the 50th percentile, might represent the real middle value. That's why they actually use the median there, because that represents the middle value. So we got the minimum 25th percentile, 50th percentile, 75th percentile, and the maximum. Okay, now this is for females. Alongside of this, it plotted box plots on the same graph, and alongside this, we see the females, and we can kind of see here that the average height in general, female heights are less than male heights. So we're getting a lot of information from this. Anybody know what that little dot is above that top whisker? Okay. Somebody reported missing the sound. I guess not. You're not missing my sound. Hopefully, that whoever had that problem, it's coming back for him. Okay. Yeah, it's an outlier. Okay. In other words, that's a value that's so high, a female that's so tall compared to all the other females, that you have to kind of consider that maybe there's a problem with that. Maybe that's an error in measurement. Maybe there's some reason why I should be omitting that. Okay, but you have to justify that. We'll have to look at it. The way SPSS figures out whether it's an outlier is it takes a look at these quartiles, and it figures out that if it's more than a certain multiplier of the top quartile away from the 75th percentile, then it says, gee, that's an outlier. So it's not making a real intelligent judgment about it. It's just warning you that, gee, it's a little bit further away than I would expect. It's up to you to make that judgment as to whether it's really an outlier. Okay, so that's the way we would use something like this. Just want to show you one other thing about SPSS, and I'm going to give you guys an exercise in SPSS so that you get a chance to open it up. It'll be something relatively simple, similar to what we just did here. Just want to show you one other thing. If I click on this or any one of these boxes, I'm going to start with this box here, and I say copy. If I go to Microsoft Word, I can click into a Microsoft Word document and say paste. And it takes that box and puts it into paste. Notice how it's a little awkward because it's outside of the margins that I normally would type in on this document. And if I click in here, look at all these complex tabs that are all over the place. It'd be very difficult to kind of work with this thing. Nice thing about it is that if I need to change something or highlight something, it's fairly easy to do. However, I lose a lot of flexibility in terms of moving this around and displaying it properly and working with it in a Word document. Instead of that, I'm going to undo that. Instead of that, I'm going to go up here to edit and paste. And instead of saying paste, and you'll see this on Word, on your Microsoft Word on PC as well. Instead of saying paste, I'm going to say paste special. You'll also see this if you use paste on the ribbon, say paste. There'll also be, if you hit the little down arrow to extend that paste command, you'll see it'll give you some choices like this as well. Paste picture instead of pasting text or formatted text or style text. I'm going to say paste picture. What's going to happen now is that it's going to change it into a picture instead of a box with numbers and tabs and so on and so forth. What that allows me to do is click it in Word, and I can easily make it smaller. I can center it. I can, if I highlight that in the row, I can center it. I can move it to another part of the document and so on and so forth. You can do the same thing with all of these graphs. So here I'm going to edit, copy. I'm going to go back to Microsoft Word. I'm going to space down a little bit. Let's see if I can't do this easily. I'm going to say paste special. Of course, this is a picture already, so it's only going to get that choice. And put it in there, and I can move this around, resize it, move it around as well. Okay. So there's a lot of things that you can do with this. This will make it a little easier for you to work with it in Word, so that if I give you a homework problem, instead of giving me an SPSS file that might be difficult for me to open, you can copy, comment on this in a Word document, add the tables that are relevant to it, and answer questions much more efficiently. Okay, so we're going to work on that, and I'll support you as you go through. You're going to be a little bit shaky in the beginning, but you'll learn it pretty quick. The last thing I want to talk about on SPSS is I want to just show you one other thing. I'm going to open another data file, that other data file that I was talking about. Open, data, and I'm going to go into my files. I want to open that diabetes file. Well, the problem is, look, it's grayed out. I can't get to that diabetes file. Okay, so what am I going to do about that? Well, the reason I can't get to the diabetes file, because it's not an SAV file, it's not a SPSS data file. And the reason why it's grayed out is because currently SPSS is only looking for SPSS data files. I can tell it, well, also look for Excel files as well. Well, look at that. Now, all of a sudden, those are not grayed out anymore. And I can click on that and ask it to open that file. SPSS will open Excel files and examine them. And it notices that it has 3 columns of data, A to C, A1 through C101. And we know that we have 3 columns of data from A1 to C101. So that looks right. And it also has a little checkbox here that says read variable names from the first row of data. You guys remember that that first row was ID, diabetes, and stay, number of days to stay. Okay, so I'm going to click OK. That looks about right. SPSS will it'll make some comments in the output window, but it'll open the data file and it'll display it for us. Okay, so now one little difficulty here is that SPSS doesn't know what the ones and the zeros stand for. We're going to talk about that next week, but for the moment, we know that the ones and the zeros are diabetic and not diabetic. And you can go ahead and you can do your analyses for diabetic. For the length of stay is going to be what we're going to find the average, and diabetic is a category, is a nominal variable or categorical variable, and you can go ahead and do the same analyses we did for height for length of stay. Okay, so we're going to get away from that. Just want to show you that you can import an Excel file into SPSS very easily. Okay, are you guys comfortable with that? If you had to, could you, and we had this video up, do you feel like you could say, do what I did with the height file with that diabetes file? Opinions? How do you feel about that? Yeah, not too bad, right? I mean, if you looked back, if you were able to look back at it, you'd be able to do that, right? Okay, so now we're going to